All right, so the whole reason that we factor polynomials or factor anything is so that we can solve, whether it's quadratics, cubics, any type of a polynomial. The reason that you want to practice factoring is so that you can actually solve. So once you see this equals 0 in here, we're going to now try to factor this, but factoring it with the goal in mind to be able to solve for what x would be. What number, if you cube it, subtract 8 times that number squared plus 16 times that number gives you 0. So there's a few things that we need to do to be able to make this work. First of all, it's got to equal 0. Okay, so you're going to move all terms to one side and set the equation equal to 0. Sometimes, look at most of the time they do it for you. Over here, you'll have to move some. Okay, next is you just factor. Okay, so we're going to look over here and factor it completely. That means as far as you can go. So notice right here, they all have an x term in them. So let's factor out an x. We're left with an x squared minus 8x plus 16 is equal to 0. Okay, and we can keep going. This is a lovely trinomial, so we can factor this into two binomials right there. And we've got an x, what is it, just minus 4, and an x minus 4. Remember, we're trying to find the two numbers that multiply to this last term. Okay, so 4 times 4 gives me 16, but they've got to add or combine here to give me this negative 8. So we've got, when I check this, you've got your x squared, got a negative 4x, another negative 4x, that'll give you your negative 8, and then a positive 16 right there. All right, so now that you got it factored, notice here that I've got 3 factors. When we say factors, remember they're just things that are multiplied together. So there's an invisible multiplication right there. There's also an invisible multiplication right there. These 3 things are all multiplied together. So we're going to set each of those factors equal to 0 and solve for them. So basically, you just take it one at a time. You say x equals 0, solve. Well, it is solved. That is just one of your answers. Okay, then you take the next factor, x minus 4. That's equal to 0, and you solve it. So when we solve, again, we're just remember, whatever you do to one side of the equation, as long as you do it to the other side, that's fine. So we add 4, and x is equal to 4. That is it, solved. Okay, and then you do the same thing with the last factor, which happens to be the same as this factor. So it is, again, x is equal to 4. Okay, so there's actually 2 answers. You don't need to write those down twice. We'll learn about this later on. It's called multiplicity 2. You get the same answer twice, but you don't need to write them down. You could just say x is equal to 0 or 4. Those are the 2 answers that will make this a true statement. Okay, all right. So again, we're trying to make it so that when you multiply, remember, we've got this 0 product property. If any of these 3 factors are 0, if this is 0, 0 times anything is 0. Same thing if any of those factors. That's why we're setting them all equal to 0. I should have said that equal to 0. And then that is equal to 4. Okay? All right, let's look at this next one right here. This is a trinomial. I don't see any I didn't see any common factors there because there's no x's over here. So we're going to factor this as our 2 binomials. It's already equal to 0 as well. So I've got an x squared in my first term, x squared in my first term over here. Now I'm trying to find 2 numbers that multiply to this negative 42, but add to a positive 1. So I know 6 times 7 gives me this negative 42. But if I have a negative 6 and a positive 7, then I've got a 7x squared minus 6x squared, which gives me that 1x squared. All right. Okay, so that was step 1 and 2 done. So we're going to go on to step 3, set each factor equal to 0. By the way, double check to see if you can't go any farther. But this is not a square. It's not a difference. It is a difference, but it's not a difference of squares because that's not a square. That's not a difference of squares. So that's as far as you could factor. But we're now going to set each of these equal to 0, x squared plus 7 equals 0, and then solve them. Now, some of these you're going to have to, if you've got some quadratic equations, you're not going to be able to factor them anymore because we factor it as far as we can. So you might have to solve by other methods, by the square roots method. That's what we're going to use for this one. Completing the square, I think we'll use that for this one. And some of you guys are really good at and like the quadratic formula. That's fine if you like that one. I don't like it, so I try not to do that method. But this square roots is going to come in a lot. Now, this one is also the easiest method to solve by, so that's nice that most of them are going to be the square roots. Basically, all you're going to do is solve for the x squared or w squared, whatever squared it is, and then take the square root. So we're going to get that x squared all by itself. So just add 6 to both sides. So you got x squared is equal to 6, and then you just undo this square. So remember, we undid subtraction by adding. We just do the opposite operation. So the opposite of squaring a number is taking the square root of that number. So x here is equal to, please, please, please note, you're actually going to have two numbers, two answers for all of these. Okay, so whenever you take a square root, you're going to have the plus and minus, and then go ahead and just write that square root of 6. You cannot simplify that anymore. So that's actually two answers. A positive square root of 6 and a negative square root of 6 will both work in there. And then we come back and we finish this one. We subtract 7 from both sides. So x squared is equal to negative 7. Do the same thing. You're just going to undo that square. Let's do orange here. We're going to undo that square by taking the square root. So x is equal to plus or minus. How are we going to write this? That negative is actually going to come out as an imaginary number, is an I. So you're going to write an I right there, and then just the square root of 7. So I root 7 plus or minus I root 7 is two more answers. Okay, notice, by the way, your highest power, that tells you how much, that tells you the most number of zeros that you could have. Okay, so you could have 4 at the most. Most of the time you will have that many. Over here, notice that 2 of them were the same. So we did get 3 answers, but 2 of them are the same. So it looks like we only have 2 answers. But just always be careful. That'll kind of help you to remember it's plus or minus when you're trying to find 4 answers. We get that if you use the positive square root of 6, negative square root of 6, positive I root 7, negative I root 7. And those are your 4 answers right there. Okay. All right, couple more of these. Again, they've already set it equal to 0 for us, so we get to factor. This is our new type of factoring that we learned this year. Notice it is a difference of cubes. Okay, this is just x to the third right there. This is just 6 to the third. So we can rewrite this. If you'll remember, this is our binomial times our trinomial. Okay, and I'm going to go through and fill in the signs. It's the same sign. Remember our SOAP acronym. So the same sign, the opposite sign, and always positive for that last one. Okay, these first two terms, they're just our A and our B, our first term and our last term. Then we're going to square them here. So x squared and 6 squared gives us 36. This middle term is just our A times our B, 6 times x, or 6x right there. All right, now it says, now we're on to our third step. It says to set each factor equal to 0. By the way, you cannot factor this farther. Okay, there's not two numbers that multiply to 36 and add to 6. That's why this was just our formula right there. So we're going to split them up. We're going to say that x minus 6 is equal to 0. Solve that one. And then this x squared plus 6x plus 36 is equal to 0. And solve for that one. Okay, this one's nice and easier. It's what we call easy. It's called a linear equation. We just have our x to the first power. All you're going to do is add 6 to both sides, and x could equal 6. Okay, so if you plug in 6 here, 6 to the third is 216. 216 minus 216 is 0. Now, there are 2 more solutions. Now, sometimes they're not real solutions. They might be imaginary. Remember, these were imaginary solutions over here. But we do want to find 2 more. So we know we can't solve this one by factoring. So remember, there were a few other methods. We could use the square root method. Now that works if you've got an x squared, but no x term. Notice here I've got an x squared and an x term. So I cannot use that square roots method. This next one, this completing the square, is one of my favorites. I like to complete the square if I've got a 1 in front of my x squared and if my b term or my number in front of my x is an even number. So some of you guys will remember we did this a couple units ago, but what I do is I get my x squareds and my x's on one side, and I'm going to move that 36. I'm going to subtract that 36 and move it to the other side, so I've got a negative 36 over there. Okay, now I notice that there's this big gaping space right there. It's because I'm going to make a trinomial. It's a special kind of trinomial. It's called a perfect square trinomial that I can actually write it as a binomial squared. So what you're going to do, I always come down and do my binomial first, actually, and I'm going to just take half of that b term. So this is just going to be x plus 3 in that square. Now, those of you guys who remember, when we square a binomial, let's just come off here to the side and do this. We're going to actually multiply it by itself. So x plus 3 times x plus 3. Don't just square both terms right there. You've got to do 4 multiplications. So you got that x times x, which gives you x squared. That's what I have as my first term. Then I've got a x times 3, or 3x. But you've also got to distribute this 3 to both terms. So you've got another 3x. Okay, so 3x plus 3x gave me that 6x that was there. But the 3 times 3 gives me a 9. So I'm missing a term. I need a plus 9 in order for those things to be the same. Okay, so I'm going to go ahead and just add that 9. Let's do it in a different color. Let's do it in orange. So we're going to add that plus 9 over here on the left side of the equation. Remember, if you go around adding 9, it's fine and dandy as long as you add it to the other side as well. Okay, so negative 36 plus 9, that'll give you a negative 27. All right, now we can go ahead and solve this. We're going to take the square root. We're going to undo that square, so just take the square root of both sides, kind of like we did over there. And we've got just what was left under there. Remember, if you square something and then square root it, you're back to what you started with at x plus 3. And there's 2 answers over here, plus or minus. Now, this can actually simplify. This is a negative 1 times 9 times 3. And if you don't remember this, I'll give you some other videos you could kind of watch to brush up on this. But the square root of negative 1 is your I. That's where the I comes from. Square root of 9 is 3. And then the square root of 3 cannot simplify it. So it's going to stay under that radical right there. Okay. And then the last thing you're going to do is you're going to, let's see, do I have any more room down here? A little bit more room. You're going to subtract 3 from both sides of the equation. Usually we kind of just stick it right in front of that. So I'll write it right here. So you've got just an x is equal to, I like to write that negative 3 first, plus or minus 3 times I times the square root of 3. And that is our final answer right there. Nice and fun, right? Okay, let's try one more. I'm not sure, but I think this one might be a quadratic formula type question. Let's look. So this one we have to do step 1. We've kind of forgotten about step 1 because it was already done for us, but remember we want it to equal 0 at the first. So I'm going to subtract an x squared from both sides. I'm going to subtract a 1 from both sides. So now I have it equal to 0 over here. So let's see what is equal to 0. Well, it's 5x to the 4th. 13x squared minus 1x squared is 12x squared. Negative 8 minus 1 is negative 9 right there. And then let's keep going with this. Notice there's no common factors, so we get to do a guess and check method right here. Let's guess. So we're going to make 2 binomials right here. Let's guess 5, because 5 and 1 are my only numbers. We're going to do an x squared. So 5x squared times 1x squared gives me my 5x to the 4th. My last terms, let's just do a 3 times a 3, which will give me a 9. And when you check them, remember you're going to check your outside terms. That's going to be a 15x squared. And your inside terms, that'll be a 3x squared. If you make this one a negative, subtract right there, then you've got your positive 12x. So make that one a plus right there. And let's go ahead and erase our checking. We checked it, promise it worked all great. Okay, now that it's factored right here, now we're going to set it equal to 0. So we're just going to take that 5x squared minus 3, equal that to 0. And an x squared plus 3 equal that to 0, and solve for both. Okay, so no quadratic formula needed here. These are both just that you just have to solve for x squared right here. Let's do this one. This one's easier. So we're going to just start with this one. So subtract 3 from both sides. X squared is equal to negative 3. So when you take the square root of both sides, remember plus or minus, it's a negative. So you're going to have an I right there. And then the square root of 3. Okay, so that is 2 answers. There's another 2 answers right here. Let's add our 3 to both sides. So 5x squared is equal to 3. Divide by 5. So x squared is equal to 3/5. I am just going to tell you on this one. This one can get a little dicey when you try and simplify this more. Let's come up here and do this. Sorry. X squared is equal to 3/5. So when you go to take the square root of it, x is equal to plus or minus. I would be fine if you left it as the square root of 3/5. If you would really like to be correct, let's go ahead and just write it as the square root of 3/5. That's fine. That is a great answer. It's probably what most of you are going to do. There is a rule in math. They do not like radicals in the denominator. Remember, these are just, you could break that apart. So what they would do is they would, whatever's in the denominator, if you multiply both the top and the bottom by that number, it will actually get rid of the radical in the denominator. So here you're just going to smash them under 1. 3 times 5 is 15. So that'll be the square root of 15. Square root of 5 times the square root of 5 is square root of 25 right there. And that works out perfectly because we know the square root of 25 is what? Square root of 25 is just 5. So this could be your answer as well. If you'd like to write it in correct form, some of your calculators will just put it in that form for you. But I would be okay leaving it without it being rationalized as well. All right. That is this lesson completely finished. There was all of our factoring and solving by factoring review.